Let's do exercise 7a. Question number 1, Roman number 5. A m1, A by m1 and A m2, A by m2. Solution. Given points are P A m1 A by m1 and Q A m2 A by m2. Then x1 equal to A m1, y1 is equal to A by m1 and x2 is A m2, y2 is A by m2. Now let's find out the distance between these 2 points P and Q by using the distance formula. PQ is equal to square root of x2 minus x1 all square plus y2 minus y1 all square. That's equal to, let us substitute the values. x2 is am2 minus x1 am1 then all square plus y2 is a by m2 minus y1 is a by m1 all things square. That is equal to square root of, there we can see a is common, so that a can be taken outside. A into m2 minus m1 all things square plus, there also a is common, so remains 1 by m2 minus 1 by m1 all things square. Square root of, now let's take the square, a square into m2 minus m1 then square plus, here also take the square, a square into 1 by m2 minus 1 by m1 all things square. That's equal to, now look at, there we have 2 terms under the root, a square m2 minus m1 all square plus a square 1 by m2 minus 1 by m1 all square. So there, look at these 2 terms, there a square is common, that a square can be taken outside, so we get a square into m2 minus m1 square plus, that a square outside, remaining 1 by m2 minus 1 by m1 square, close the bracket. That's equal to, let us take the square root of a square. Square root of a square is a, that can be taken outside, so remaining m2 minus m1 all square plus 1 by m2 minus 1 by m1 all square. That's equal to a into square root of m2 minus m1 all square plus, there 1 by m2 minus 1 by m1, there we can take the LCM and subtract. LCM is m2 m1 There we numerator we get m1 minus m2 then all square is equal to a into square root of m2 minus m1 all square plus m1 minus, okay, then separate the square, the numerator and denominator, m1 minus m2 square by, take the square of the denominator, so we get m2 square m1 square. That's equal to a into square root of m2 minus m1 whole square plus, now we need to remember one thing, m1 minus m2 whole square and m2 minus m1 whole square both same, so it can be written m2 minus m1 square by m2 square into m1 square. That's equal to a square root of, now look at there, m2 minus m1 square here, and the second term also we have m2 minus m1 square, that can be taken outside, so we get m2 minus m1 square outside, so remaining from here m2 minus m1 square outside remains 1. From there m2 minus m1 whole square outside, so remaining 1 by m2 square m1 square. First we can write m1 square, so m1 square into m2 square, close the bracket, equal to a into square root of m2 minus m1 square. Take the LCM and adding. So when you take the LCM, we get m1 square, m2 square is the LCM. Then the numerator we get m1 square, m2 square plus 1. A into square root of, when you multiply we get m2 minus m1 whole square into numerator m1 square m2 square plus 1 by m1 square m2 square. A, now we can take the square root. Square root of m2 minus m1 square is, it should be m2 minus m1, and denominator we have m1 square, m2 square, its square root comes m1 m2, but when you take the square root it should be plus or minus, so we could write that one absolute value of m2 minus m1 m2. Then under the square root remaining only m1 square m2 square plus 1. So it can be written 1 plus m1 square m2 square. This is the answer.